Hi everyone, in this video I am going to discuss question number 2 of 2019 end semester examination paper. So let's move into the problem. In this problem, part A, you are given two similar matrices A and B, and there are another two similar matrices which are B and C. You have to show that A and C are similar matrices. So I think you already know what are similar matrices. That means if A and B are similar, so I will start the question from here. So I can write if A and B are similar matrices, or if A and B are similar, I can write the matrix A as PB P inverse. I think you know this definition. So P should be a invertible matrix. So like that, I can say that if B and C are similar, then I can write the matrix B as Q C Q inverse. I can substitute B to this side and I can write down A as A equals to P into B. B is Q C Q inverse P inverse, and I can write this as PQ times C times Q inverse into P inverse is PQ inverse. So now I can tell that A and C are similar because I wrote A as a matrix times the matrix C into the inverse of the matrix PQ. So therefore I can say that this will imply A and C are similar matrices. So I proved that if A and B are similar and also B and C are similar, then I proved that the matrix A and C are similar matrices. So now I will move into part B of this problem. So that is the most important part of this problem. So let's move into that part. So in this problem, you are given a basis B, that is U1, U2 and U3. Basis B is equal to U1, U2 and U3, and there is a linear transformation from vector space V to vector space V, and this B is a basis for vector space V. Right. And you are given the matrix representation of this linear transformation. So that is TB. So TB is given as minus 3, 1, 0, 4, 0, 1 and 7 minus 2, 0. So this is the matrix representation of this linear transformation. So if we are given the matrix representation of any transformation, then we can write the transformation. So I think you know these stuffs from your theory notes. So now I can write that what is TU1. So TU1 will be minus 3 into U1 plus 1 into U2. That is equal to minus 3 U1 plus U2. So these two are the corresponding coefficients to T1. Right. Now I am going to write TU2. TU2 will be 4 into u1 plus 0 into u2 plus 1 into u3. So that is equal to 4u1 plus u3. So these are my coefficients to TU2. Now I am going to write TU3. So if I write TU3, then I will obtain 7u1 minus 2u2 plus 0 into u3, that is equal to 7u1 minus 2u2. So this is TU3, and I obtain the coefficients from this column. Right. Now I expressed the linear transformation in terms of u1, u2 and u3. Right. So now the problem is you are given another basis v prime, that is v1, v2 and v3, and it is defined v1, v2 and v3 also, and you have to represent this linear transformation in terms of or with respect to the basis b prime. So let's do that part. So my basis b prime is v1, v2 and v3, and it is given that v1 equals to u1 and v2 equals to u2, u1 plus u2, u1 plus u2, and v3 equals to u1 plus u2 plus u3. Right. From this I can find out what is u1, u2 and u3 in terms of v1, v2 and v3. So u1 is equal to v1, that is easy, and also if you find u2, that will be v2 minus v1, and if you find u3, that will be v3 minus v2. Right. Now I am going to find what is TV1, TV2 and TV3. TV2 and TV3. Right. So what is TV1? So I already know V1 equals to U1. So TV1 is equal to TU1, and TU1 is minus 3U1 plus U2. I wrote this from here because I already know that TU1 equals minus 3U1 plus U2. I need to express TV1 in terms of V1 and V2. Therefore, I will convert this into V1 and V2. So I know that U1 equals C1. So minus 3V1 plus U2. U2 equals to V2 minus V1. So I will get minus 4V1 plus 1 into V2 plus 0 into V3. So I found that dV1 equals minus 4 into V1 plus 1 into V2 plus 0 into V3. I think that part is clear for you. So next I am going to find TV2. TV2. I know that V2 is U1 plus U2, so I can insert U1 plus U2 instead of V2, and from the linearity I can write this as TU1 plus TU2, and I know what is TU1 and TU2, and TU1 is minus 3U1 plus U2, and TU2 is 4U1 plus U3, and I will get U1 plus U2 plus U3, and it's clear that U1 plus U2 plus U3 equals V3. So I can write TV2 as 0 into V1 plus 0 into V2 plus 1 into V3. Right. Next I am going to find TV3. I know that V3 equals U1 plus U2 plus U3, so I can write TV3 as T into U1 plus U2 plus U3, and as I did previously, from the linearity you can say that this is equal to TU1 plus TU2 plus TU3, and now you have to substitute for TU1, TU2 and TU3. TU1 is minus TU1 plus U2, and TU2 is 4U1 plus U3, and I need to insert TU3. TU3 is 7U1 minus 2U2. 7U1 minus 2U2. And if you simplify this, you will get 8U1 minus U2 plus U3. Right. Now you need to insert for U1 and U2, U1, U2 and U3 in terms of V1, V2 and V3. I know U1 equals V1 and U2 equals V2 minus V1 and U3 equals V3 minus V2, and I will get my answer as 9V1 minus 2V2 plus V3, and if I write TV3 I will end up at 9V1 minus 2 into V2 plus 1 into V3. Right. Now I finished writing TV1, TV2, TV3 in terms of V1, V2 and V3. Again I will write them in a separate place. I found that TV1 equals minus 4V1 plus 1 into V2 plus 0 into V3, and I found TV2 equals 0V1 plus 0 into V2 plus 1 into V3, and TV3 was 9 into V1 minus 2 into V2 plus 1 into V3. Now I can write the matrix representation of this linear transformation with respect to the basis B prime, because I expressed TV1, TV2, TV3 in terms of V1, V2 and V3. So my first column should be these three elements, that means -4, 1 and 0, and my second column should be 0, 0, 1, and my third column will be 9, -2, 1. I think you understood this discussion clearly, and if you have any doubts you can email one of us, and again go through my simplification and find out if there's any simplification mistakes. I think there are no mistakes, but again go through the method that I have done this problem, and please ask if you have any doubts. So I am going to finish this recording from this point. Thank you for watching.